That's right. Howdy, everyone. My name is Jordan Bean. I'm an app innovation technical specialist at Microsoft. So I've been a software developer for about 15 years. And so app innovation is all about helping you build applications. And so the point of the presentation today is to talk about OpenAI, but specifically in the context of building applications. How do you build and architect an application that uses OpenAI? How do you think about it? How do you design it? So there'll be a couple of different demos, and all the code and all the samples and everything I'm going to show you is available on GitHub. So you will get everything. So don't feel like there's anything secret or proprietary here or that you have to ask for the material. All of it's on the internet already. So you have access to all of it, and we'll send out everything afterwards. Okay? Okay, so the first thing to lead off with, and the most important first message is always, just like every other service in Azure, the data that you put into OpenAI is yours. It will never be used to train the foundational models that we go sell somebody else. If you run the OpenAI service in Azure, you have your own private instance of that service. And so that means if I spin up the service and I ask a question about your company or your data, OpenAI will not answer. You have your private instance of it, just like you have your private instance of a SQL database or a Databricks instance or an app service or anything else you deploy in Azure. OpenAI is just another service in Azure. And so that's how it's differentiated from other large language models that are out there and other ways that you can purchase those services. In Azure, everything is private to you. And you can control the network, you control access to it, you can set up RBAC, but all the data is yours. So that's the most important first question everybody asks about it is, are you going to go sell my data? Or are other companies going to see my data? No, no, no. The OpenAI service is a private instance just for you. Okay? So that's the first thing to keep in mind. Now the whole idea is the OpenAI company is separate from Microsoft. They created the large language models that we're familiar with, the ChatGPT models. You're getting an instance of those models in your Azure subscription that you can use on your data and to bake into your application. And so there's a couple of different models you can deploy, the GPT models, which are the most famous, the chat ones. But there's other models around transcription and translation. There's models for generating images. There's different ways to pay for it depending on how much or how little throughput you want. And you have the ability to have it call out to external functions. So I'm going to show you some of these interesting things as we go through the presentation today. Are there any questions so far?
So did the royal family use DALL-E to put up that fake picture?
I don't know. Kate Middleton apparently has gone back and forth on whether or not she did some fancy editing or what she did with it. All right, so I'm in what's called the manufacturing sector at Microsoft. And so specifically, I support manufacturing companies. And so we've identified an enormous number of potential use cases for generative AI solutions. And so we see all kinds of things from summarizing documents, generating documentation, things like GitHub Copilot to help you write code faster, summarizing legal documents, looking inside legal documents to see what's written in them, procurement departments looking at all of the contracts that they've signed and asking, what on earth did I sign? What has our company agreed to? There's a huge number of use cases, and there's more all the time. But the easiest one to explain and understand from designing an application point of view is that customer support chatbot. And so that's the one that we're going to focus on because it's the easiest thing to do. It's the easiest thing to understand. Everybody can understand what it does. But the important part is to understand the architecture, the ideas, and how to think about building it. The code part is less relevant, not because you don't have to have code to do it. You do. But the code is not really that hard. And that's part of what Semantic Kernel does is it makes it the code part easy. The important part is architecting and designing the solution. And so that's the point of the presentation, is to walk you through how to architect and design these apps. Okay? So like I said, you have your chat models, you have Codex models, you have DALL-E models. Now the Codex models are really cool. They're not the ones we're going to focus on in this presentation, but being able to have generative AI write code for you, like GitHub Copilot does, is really, really powerful. Not just for writing code like C# or Python, but writing SQL. If you want to ask a question of your SQL database, you don't have to be a SQL expert. You can use human language to say, tell me all of the customers in Texas named Jane, and it will go generate the SQL query for you. As part of the model, or as part of the data you pass into the model, you give it the schema, and it can generate SQL. We've also seen customers do this with ADX. We've seen them do this with a bunch of other tools in Azure. We've even seen customers do it on their own domain-specific languages. Like if your company wrote your own domain-specific language for something that you sell, OpenAI and generative AI can help customers generate the scripts that run inside your applications. So that's another use case that's starting to pop up that's beyond just the chatbot. But the one we'll focus on today is the chatbot. Okay? So how do we build an application and how do we architect it? Okay, so in this case, we need something to run our code. So that'll be app service, web server is a service, and we deploy the OpenAI model. Okay? So if we deploy those two services, is that enough to have a chatbot for our data? Maybe. Okay? So we're going to set up the bot. This is our system prompt. This is how we tell the bot how to behave. Assistant, you are going to help Contoso employees with their internal healthcare questions. Okay, so we've set up the bot. This is how we want you to behave. The first question comes into your chatbot that you've deployed. Does my plan cover annual eye exams? Can OpenAI answer that question? I see some people shaking their heads no. Why not?
Doesn't know what my plan is.
That's right, exactly. By default, the OpenAI service cannot read all of your data. Deploying it to your Azure subscription does not magically let it read all your data. It's trained on the internet, it's trained on blog posts, and it's trained on news articles and stories. It's trained to understand human language, but it does not have access to your data by default. And so it can't answer questions just by deploying the service. Okay? So then you may come up and say, all right, well, I'm going to deploy these services, set it up, and I'm going to give it access to all my data. I'm going to inject all of my data, all my PDFs, all my SQL databases, all my PowerPoint documents, my Word documents, everything my company has to answer any question that might come in. I'm going to build a generic chatbot that can do it all. Will that approach work?
No.
No. Why not?
Still doesn't have customer-specific data.
Well, in this case, we're injecting it all. We're saying all of our customer-specific data that's in our PowerPoints or whatever, shove it into every single question that happens against the chatbot. Will that work?
But it wouldn't have it for that specific person? Are you saying it would have the individual plan data for that individual?
So in this case, we just mean more generically all the data that your company has about healthcare, like all your HR SharePoint data. Shove all of it in.
Right.
And then can OpenAI answer a question based on all that data? It's too much data. So you can't just put all of your data in. There's always going to be what are called token limits. So when you pass data into the generative AI models, there's always limits. Like the ChatGPT-3 models could do 4,000 characters. There's ones that can do 16,000 characters, 32,000 characters. There's even some that do 100K. But there's always a limit. You can't put everything your company has. But more importantly, you don't want to. The more data you give the generative language models, the more likely they are to hallucinate and to make stuff up. Because they just have this giant amount of data and it's not relevant to the question being asked. You can't give it everything you've got and hope and pray that it can figure out an answer. Just like you can't throw an encyclopedia at somebody and expect them to be able to answer everything, or take a doctor and expect them to be able to answer IT questions. There's too much. They don't know. There's too much information. So we need to pare down the information to just the parts that are relevant to the question the user is asking. Okay? So the way that we'll do that, the pattern for implementing this is called RAG, the Retrieve, Augment, and Generate pattern. And so the point is, it doesn't matter what language you implement this in, whether it's C#, Python, Java, it doesn't matter. The important part is the pattern. If you implement the pattern, you can do it in any language you want to, but the pattern is what is important. So we're going to set up our bot in a very specific way. We're going to say, hey bot, answer healthcare questions. Only answer questions based on the facts below. You don't see the facts yet, but that's how we're telling it we want it to behave, because we don't want it to make stuff up. People care about their healthcare plan questions, and it's very important that A, we answer them correctly, and B, we have a reference to where did that answer come from. Okay, so we're going to set up our bot to behave that way. So this is part of the prompt engineering of explain to our bot, this is how I want you to behave. Okay, so now a question comes in, does my plan cover annual eye exams? So instead of trying to directly answer the question, we need to get some data out of an external system. Okay? So we're going to take that question and we're going to pass it off to a search engine, like Azure AI Search. This used to be called Cognitive Search. That search is a search engine. It can index anything. It's really good at PDFs and PowerPoints, but technically it can index SQL and other things as well. And it's just a search engine. It's just like Google and Bing. You point it at your data, at your blob storage, at your SharePoint articles, wherever you've got your data, and let it index it with normal search engine technology. There's nothing magic about what AI search does. It's just a search engine. It uses the same search technology that we've had for 20 years. But you point it at your data. So you upload all your blobs, all of your PowerPoints and PDFs and whatever into blob storage. You can point it at your SQL databases or anything else you want to index. And it's just going to use search engine queries and return back some data. Now, AI search is just a search engine. It's not human language. It's looking for keyword matching. So it's going to return relevant data, but it doesn't know exactly what the right answer is. But it's going to say, hey, there's 4 different documents that have something to do with healthcare plan questions. So pull some snippets out of all those documents and inject it into the prompt. Okay? So the prompt, you notice, has changed. If we go back to the previous one, we didn't have all those facts. Now we're going to add those facts in. This is the corpus of data we want the system to answer a question over. Okay? So rather than all the documents that could possibly be on SharePoint that may or may not have anything to do with healthcare questions, we had a search engine go find the documents that are specific to healthcare, then inject those or do string concatenation with our original prompt. Now we've got the data we want OpenAI to search over to try to come up with an answer. Okay?
Wouldn't it, or couldn't it also look at the person who's doing the asking and determine if they're on plan A or plan B?
Absolutely. Yep. Yeah, and so that's called function calling, and we'll talk a little bit about that soon. But yes, absolutely. We want it to get even more specific as we go along. But this is the generic pattern to follow, and then we can talk a little bit about how function calling would work. So we've got our prompt, how we want the bot to behave. Now we've got relevant snippets of potentially correct answers, but all in the realm of the question that was asked. Now OpenAI can look at those facts, the original user's question, and say, oh, number 2 best answers this question. So now I'm going to return back to the user and say, yes, your plan covers annual eye exams, and here's a reference to the document where I got that data from. Okay? Now, obviously, you can make this more and more complicated, but this is the basic idea of the RAG pattern. And you'll implement this no matter what your data type is, no matter what data store it happens to be in. This is the generic pattern you're going to write in code and build yourself.
And I guess in the case of this Azure OpenAI Studio feature, when you do bring your own data for like a PDF document, let's say, think of PDF documents comprised of a set of images. Does it automatically set up the stuff that will do OCR on your PDF
Yeah,
images?
we'll talk about that in just a second, but yes, absolutely. Yep, go ahead.
Furthermore, on the AI search here, is it just a keyword search on your data, or is it a vector database? Is it doing embeddings and more complex?
It depends on how you set it up. So by default, the original AI search was just about keyword matching. It had some semantic search built into it, but ultimately it was the same stuff you would get on Google or Bing. Recently, AI search within the last year has added that ability to store the embeddings or the vector representation of data, and you can use it as your vector data store. And so you can send your query out to AI search, retrieve back the relevant documents based on the embeddings match, and get the data back. Adam, go ahead.
Embeddings, please? I don't know that. And vector search?
Yep.
Yeah.
No, let's talk about that. Sometimes people are interested and sometimes they're not. All right, so let's talk about that. Let's make some slides. Okay, so the idea is we need to convert human language to a mathematical representation that a computer system can understand. Okay, so we're going to break up whatever query is passed in or whatever data we need to index. We're going to break it up into tokens. In the OpenAI system, a token is something on the order of 3/4 of a word. It's kind of like a syllable, mostly. And it's about getting rid of words that don't really matter, like ums or these. It's getting rid of some of those words. But it's converting human language into a mathematical representation. Okay? So that's tokenizing what you pass in. But one of the innovations that came out of the OpenAI company was how do we predict the next word? Because that's really what everybody wants out of the large language models is how do you predict the next word? What does the machine need to respond with? Just like as you're listening to me, you are predicting what I'm going to say next based on the words I've said before or the knowledge you already have. We need to make that same kind of representation mathematically so the large language models work. And so under the hood, this is what they do. They take the mathematical representation of words, and then they compute a vector that represents that word and all the other words that are related to it based on the training data. So if you look at literature and you look at songs and movies and other stuff, the word king and man often appear together. Therefore, their vector representation is going to be similar in a similar direction with a similar magnitude. And the word queen and woman are often appear together. And so those are going to have a similar vector, a similar representation mathematically. But the word hot dog is not. The Queen of England probably isn't eating very many hot dogs. And so it's unlikely that if you search for the word queen, you're also looking for something to do with hot dogs. It's not that hot dogs are bad. They're just different than the queen. And so mathematically, what OpenAI did was compute these embeddings or these vector representations of words, and then through the large language model, compute how those words are related to other words, so that when you ask a question, it can go and try to predict what words are needed to answer the question. Does that make sense?
So the embedding API from Azure to feed the system my data to make it vectorized?
Yes, so the large language model itself has already been trained on human language based on whatever the OpenAI company chose as its training data. So you're not fine-tuning or you're not training the model on your data. I mean, technically that is a thing, you can do that, but most people don't need that. It's outrageously expensive and the vast majority of people don't need it. Instead, what you're doing is you're taking the pre-trained model that understands English or whatever language you run the system in. You're taking your query or your data, computing embeddings of that data, and then letting OpenAI answer the question based on the human language vector representations it has and the vector representations of your data.
Of course, if the company was Dairy Queen, it could probably find a hamburger, even if it can't find a hot dog.
Potentially, yes, absolutely. There you go. It may get confused. That's a hallucination where two words sound alike, but they're not necessarily correct. Okay? All right, so another representation of this is, and this is not the correct representation, but this is a way to think about it, is we compute those vectors, and those vectors point to a whole bunch of different directions. They have a bunch of different dimensions that they all point in. So this is a 3D representation, which is not correct, but it gives you the idea. And so we have that word that we computed, bank. We want to find the other words that are related to bank. Well, bank is a synonym in English, and there's a bunch of different words that have something to do with bank, but in a whole bunch of different contexts. So banks have something to do with money and the IMF and funding and currency. And so one direction that the vectors point in has a bunch of answers that have something to do with money. But bank also could refer to the West Bank in Israel, and so it may have words like Gaza and Palestinian related to it. It may also have something to do with South Bank, so like a river. And so there's a bunch of different potential representations, but ultimately this is what the large language models are doing under the hood. You're not doing any of these things yourself, but the system, this is how the system really works under the hood, is it is taking human language that it's been trained on, computing a mathematical representation of that data. Then when your data comes in, it can compute that same mathematical representation and try to predict the next word based on words that it's seen before. Does this make sense? Again, you're not doing any of these things. The model is already created for you. You're just using it because it understands human language. Okay? All right. So just as an example, the way these models are built is we have our data over on the far left, which is our input layer, and then various neural networks are built on top of that as the words are related to other words. And this is what OpenAI did under the hood. They're making these mathematical representations and setting up these neural networks, which is why they're so expensive and hard to create. But you don't have to do any of this yourself. The important part, though, is to understand how much data and how many relationships there are inside these models and why you don't want to do it yourself. The GPT-3 models have 175 billion of these. GPT-4 has 1 trillion. This is why these things are so expensive and why they require GPUs to create. But once we've got them, then we can use them on our data. Okay? All right. So let's keep on going. All right. Okay. So again, this is the pattern, the RAG pattern, and this is what you're going to implement in your application. So if you look at our accelerators, some of the ones I'm going to show you, this is the pattern you're going to implement to start with. Take your data, your PDFs, your PowerPoints, your SharePoint documents, whatever you've got, have AI search index them, and then in your application, you're going to query the search engine index, retrieve relevant snippets of all those documents that have something to do with the user's question, and AI search does that for you, just like you type a query into Google. You're going to get back 10 links, but you still have to go and read all those 10 links to see which one actually answers your question. This is the same idea. We're going to let AI search generate the 10 links, but then we're going to let OpenAI decide which one of those actually had the real answer and answer back to the user. Okay? So the generic idea is called RAG, Retrieve, Augment, and Generate Pattern, where you take your data, you pass it off to a different data source, a data search engine of some kind, add those results to the prompt, query the model, let the model answer the question, and you get some results back. So you're going to implement this loop inside your application. And so this is what all of the demo code I'm going to show you uses this same basic idea. This is the loop of what you actually implement. Does this make sense? Are there any questions about this before we keep going?
So who will extract the information from my question? The AI model or my code need to do that? Like,
Say that one more time.
from my question,
Mm-hmm.
the keyword to send it to AI search. Who will do this?
Right. Most people just take the user's query directly as it is and pass it to AI search without changing it, because they want to let AI search try to retrieve all the relevant documents without changing them. But that's not always the case. Sometimes you want to go in and change users' questions before they hit the AI search. So you can do that, but most people just take the query and directly pass it to AI search. Okay?
Or I can ask the AI model to just give me the keywords from my.
That is one way you could do it, yes.
Are the results ranked by is
Yes.
least probable to least probable?
AI search does give you a relevance score where it tries to guess what it thinks the relevance is based on the keyword matching. But ultimately, that search has nothing to do with OpenAI and whether it's going to agree that that's the correct answer or not. Because it's going to use human language to try to guess the right answer, where AI search is doing keyword matching and semantic analysis to guess the right answer, or to guess the relevant documents that have something to do with the right answer, but it's not going to try to answer it because AI search can't read. It can't understand human language. It's just taking keywords, just like in Google. Google doesn't directly understand your question. It's using its search engine index to find web links that have something to do with what you asked. Okay? Does that make sense?
I hope we're getting close to a question I've been wanting to ask. So you mentioned that we don't train the model on our data.
That's right.
Is that what's going on here? Because I don't understand how I can even use it without training it on my data.
Yeah, so let's go back. Let's make sure that that is super clear, because that's the key to understanding the RAG pattern, is the model, the OpenAI model, understands human language. That's all it does. It's been trained on the internet, it's been trained on blog posts and news articles and literature and movies, so that it understands how a human would think and how a human would answer a question based on the relationships between words and which words are most likely to appear with other words. So we're just using that as a tool, just like we could stick a human there where OpenAI is. Like if you were the customer service agent and you had your internal SharePoint documents, you could type in a search whenever somebody on the phone asks you a question, but you as a human have to read all those articles and decide which one best answers the user's question. We're doing the exact same thing here, but instead of a human understanding that data that comes back from the search engine, we're letting OpenAI do it for us. So this is, we do not want to train on your data. We want to search your data, find the pieces of your data that are probably relevant, and then let OpenAI make a determination based on those snippets if it is the right answer or not. And it still might be wrong. And then OpenAI could send a question or a response back saying, I could not find an answer amongst the data I have available. Could you please clarify? And then let the user type in more, go back to the search engine, let it go generate some more potential responses, and let OpenAI answer on top of that. Okay?
Right.
So the point is, do not fine-train the model. Fine-training is outrageously expensive, and most people don't need it to solve most problems. Not all. There are reasons, and we do technically sell you the ability to do it, but it will cost you a fortune, and most people don't need it.
Yeah, and the software development manager at my company seems to want to do that kind of fine tuning, but like, do you have like a price
Oh yeah.
range I can throw at?
Oh yeah. Yes, we do. Yes, we do. I mean, it's like the movie The Big Short. This is Wall Street, Dr. Burry. We will take your money if you give it to us. But most people don't need it. Okay, and so we can talk about if you want to actually do that, what it would cost, because the prices are there. But most people can use the RAG pattern and get enormous value without having to fine-train a model. And so that's what most applications you'll see implemented with the OpenAI services is following this pattern, not fine-training, or fine-tuning rather, the model. Because it's not needed, because again, what you're doing is you want to use OpenAI as a human to understand data and respond. Okay? Does this make sense to everyone? Okay. All right, so let's keep going. Okay, so people forget, but Azure's had a bunch of AI services for a really long time. This was before OpenAI. We had a bunch of other AI services, and they're still out there. There's cognitive search, now called AI Search. The form recognizer, now called Document Intelligence. I need to update the slide. There's the video indexer, and there's translation services and language services. Azure already has these things. You don't need OpenAI to do a lot of things. We already had AI models that could do very specific things. But OpenAI is the newest AI model that is part of the Azure AI services. But there's a bunch of others, and you can mix and match them as needed. And in fact, the most common use case is to mix and match them. And so how do you set up an app that does that RAG pattern? Well, before any question comes in, we have to build that search engine index, right? How do we do that? So we can take all those documents, all those PDFs, the PowerPoints, whatever we've got, and pass them into an OCR pipeline, an optical character recognition pipeline. So obviously you can use any tool you want to, but Azure does have one called Document Intelligence. This used to be called Form Recognizer. And so what this service does is it looks at your documents and it breaks them up, it extracts all the text out of them, or the images or the tables or anything it finds in them. It's called cracking the document, and it builds a search engine index on top of it. And this is part of where the magic comes in, and where some of the data science would come in is how should you chunk those documents? How much data should be in each of the entries in the index? Maybe you need more, maybe you need less. Maybe you need to index more data. Maybe you need to add more fields to the search engine index to make it run faster or to better answer the questions. So we have accelerators that can do this, but it's very likely that out of the box they'll do an okay job, and you'll probably have to customize them a little bit to better index your data. But this is the pattern. You take your documents out of blob storage or SharePoint, have Document Intelligence crack them and make an index, and now that index is sitting there waiting, and then in your web app, whenever a question comes in, you pass that data to the search engine, it comes back with relevant snippets, those snippets get concatenated with the question from the user and passed to OpenAI to generate an answer. Okay? So this is the pattern you're going to follow as you build applications. So this is the most important pattern to understand, the RAG pattern. Does this make sense to everyone? I realize I'm harping on this one a lot, but this is the key to understanding everything. Once you understand this pattern and how you're supposed to apply it, it doesn't matter what language you pick. It doesn't even matter which technologies you pick. But once you understand the pattern and how to think about it, you can build this using anything you want. Adam, go ahead.
Yeah, I was just going to add a source of confusion is that there are two key services that are used here, right? Azure OpenAI, that's the one, and then the one that you send your data to, which is Azure AI Search. So there are two
That's
pieces
right.
to this. So that's key to understand. It's not
Yes.
just OpenAI,
That's
which
right.
is what a lot of folks tend to think. that second one, the AI search, is crucial.
Yep, absolutely.
So
That's the key to understanding.
That's it.
Okay?
So what is ACS?
Let's go back. Oops. What is,
Say indexed by ACS.
let's see. So that is a typo. It's Azure AI Search.
Yeah.
It used to be called Cognitive Search. I keep trying to update the slides as Azure changes all the names on me. Yes, that's supposed to be AAS. AAS, Azure AI Search. Thank you for pointing that out. I need to fix that one. Yeah, there you go. That's right. It has nothing to do with containers. No, good point. It has nothing to do with containers at all.
Yeah.
Containers are fun, but that is not it. Very good.
Well spotted.
Excellent.
Thank you.
Very good. That's right.
Paying attention.
All right. So, and again, I'll send out everything that we've been talking about, so nothing secret or proprietary. There are multiple different implementations of this RAG pattern, depending on the language you like, what your company typically uses. So one of them happens to be in TypeScript. For the front end, it's a React app, and the back end is Python. And so if those are languages and technologies your company likes, that's a good accelerator to help you get started implementing this chat with your data pattern. If that's not the one that you like, because those aren't the languages that are typical at your company, we have another one that's in C#. So it's a Blazor-based application. So that's the one I'm going to show you in the demo in just a second. But it really doesn't matter. Use any technology you like. It really does not matter. What's important is the pattern and as Adam said, the AI search to index data and OpenAI to answer questions on that data. Okay? All right, so let's look at the sample app so that you see this idea in action. Okay. All right, so what you're looking at is a Blazor app. So this is the C# implementation. So this happens to be running in container apps under the hood. Doesn't really matter. You could run it locally, run an app service. Really doesn't matter. This accelerator happened to have chose container apps. Okay, and before the demo, I went and indexed a bunch of data. Okay, so I used document intelligence to go index this data, and there were just a bunch of PDFs. And what's cool about these accelerators is if you want to do this at your company, all you have to do is take the accelerator, delete the PDFs out of the data directory, dump your PDFs in it, and click go. And it will generate this exact same app, but on your data. So you can have this demo running in under an hour, which is the most exciting part.
If you get permissions to spin up cognitive services?
Yep, obviously you have to be able to create the Azure services, yes. But assuming you can create them, you can have this demo running on your data in an hour. Okay? All right, so I've indexed a bunch of documents, and now I can chat with my data. And obviously, if you deploy this at your company, you could go delete this part and put your company's branding and CSS on it or whatever, so it looks like you spent a lot of time building this app. But you can just steal ours and use that as the accelerator. Okay? So let's chat with the data. What is included in my healthcare plus plan that is not standard? Okay? So it generated an answer. The Northwind Health Plan includes coverage for specialty care, blah, 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 blah. It came up with an answer. What's important, though, is it implemented that pattern that you just saw, the RAG pattern. So if we look at the thought process, or more specifically look at the supporting content, what happened was when I issued that query, and I'll show you the code that does this in a second, I took that query, I passed it to AI Search. AI Search came up with these 4 PDFs that have something to do, or 3 PDFs rather, that have something to do with that question. AI Search is just a search engine. It can't answer the question, but it can retrieve relevant documents and relevant pieces of documents based on normal search engine technology that probably have something to do with the right answer. And then AI Search, or pardon me, not AI Search, OpenAI took those snippets along with the user's original question, read through it, and then came up with an answer. Okay? So this implemented the RAG pattern. Does this make sense so far? Any questions about this before we keep going?
This is an accelerator example. I mean, a typical RAG pattern, you might only get your answer, but it looks like you're adding more here, the thought process and supporting content.
Yes. So this app was written to try to make it easier to understand why AI answered a certain way, because that's usually the next question people ask is, how did you come up with this answer? Where did you get this document from? Why did you answer it this way? Do I know as a human expert that the data is wrong, or that the answer rather is wrong? Why did you make a wrong answer? It was really, really hard if all you have is OpenAI to try to understand why. Because you can't see all those layers that we were talking about. You can't see the neural network that's inside. You can't trace the path through it. But instead, to try to make it easier to understand why it made a certain answer, the accelerators often encourage you to show the supporting content, where users can see, here's the relevant data that came from the search engine, here's what OpenAI tried to reason over it, and it came up with an answer. Okay?
And you get all of this every time you use it.
With this accelerator, yes. Yeah, I mean, obviously you don't have to implement those things if those aren't relevant to your company, but the accelerators always have those so that you have the explanation of why.
How do you get the thought process? Like, do you ask the model in the same prompt that you ask the answer, hey, also tell me the thought process, or is there something like that?
Yes, so in this accelerator, the way this one happens to work, what it will do is, in the background, it will go issue another query to OpenAI saying, how did you come up with that answer? And then it's got it pre-staged to make the demos look really good. And I've got some other examples that show you in more detail how it does this, but that's the idea. Now, what's really cool about this, and what makes these accelerators really fun, and where some of the magic starts to appear, isn't just, can you answer a question, but look at all the follow-ups. Where did those come from? How does it know what it ought to prompt the user to ask next? Well, that's another query to OpenAI, saying based on the question and based on the data I got, suggest some follow-ups. And let AI generate some potential follow-ups and let the user say, yeah, that's something I'd like to know, or no, that has nothing to do with what I want to ask. Let me ask something else. Okay? So this is starting to show you that idea of AI orchestration, where it's not just the RAG pattern of one search engine query, one call to OpenAI. You can make multiple. You can orchestrate a more complicated workflow to provide a better user experience. And so that's what this accelerator is showing you. Does this make sense? Okay, so I'm going to show you some ideas of how you do this in a little bit. But this is what you need to think about when you're trying to come up with, how should I do this at my company, is what user experience do you want? How can you make a better user experience for the users that are using these systems? Like with the supporting content, to help the users feel comfortable with the answers, or to suggest follow-up questions. So for instance, at one of the companies I was helping with, they get input data from their users, but those users often forget to provide certain relevant data. So for their app, there's some structured pieces where they need to provide specific answers to specific questions, but then there's a free-form field at the bottom where they can type in whatever. And if users are lazy or they're busy, maybe they just hit spacebar, or they don't type in anything, or they just type in a little bit of relevant data. But if you have a large amount of data and you know the kind of useful information that you really wish your users would type in, you could prompt the user and say, hey, did you forget to add this extra piece of information, or did this kind of thing happen to you and you ought to note it in the supporting content or in the free text field? Does that make sense? Okay.
So Jordan, sorry, I asked some questions online regarding how to do end-to-end testing on a Blazor app like this. How would you do testing such apps?
Yeah. The trouble with OpenAI is it's non-deterministic. You can't guarantee the answers. I couldn't guarantee that the demo would actually work, and I'm going to show you a case in a minute where it's not always going to work right. This is one of the hardest things to do, and there are no good answers yet. What most companies have implemented is they will pick questions that they know they want the system to correctly answer, and they'll put those into a test framework. And then as they're working on the prompt engineering and as they're working on the workflow, just like with unit testing source code, they're having those questions be passed through their application regularly and then checking the responses. Okay, so that's one thing. Another thing that's very common, especially with the manufacturing companies I work with, is this idea of we need to check the answers for safety. So if you are a manufacturer of electrical control panels, you want to make absolutely certain that when AI responds, it doesn't tell people to touch a panel that's still energized, or to stick a screwdriver in it, or to not follow the lockout tagout procedures. And so a lot of companies will implement what they call a safety plugin, where it will take the answer that came back from OpenAI following the RAG pattern, but then pass it through another filter another plugin to say, check this answer for safety, and then they will provide, here are the common safety things that we want to make absolutely certain our system never ever does, or always tells the user to do. So when you get the OpenAI service from Microsoft, some of that safety stuff is built in. So there are safety filters for like sexual content or hate speech, or I don't know, there's 3 or 4 others. And so those are ones you get with the service. But a lot of companies implement their own. They'll add on more for specific safety things that are relevant to their industry. And so again, that's that idea of AI orchestration. It's not just find me an answer, but check that answer to make absolutely certain it's the same thing that my human experts would have advised. Does that make sense? So that's super, super common. Okay. All right, so, and again, we'll send you all of this after the presentation, but this is the accelerator that I just showed you. And this is what you can copy and implement with your own system. If you like C#, if you like TypeScript and Python better, there's another version of this that's very similar. It just happens to be built using those technologies. The magic, though, is this directory right here, the data directory. When you clone this repo locally, all you have to do is go into that data directory, and you'll notice this one happens to come with a bunch of Contoso Northwind Health Plan data, blah, blah, not real. Clone the repo, delete everything that's in that directory, and put your data in there. And then run the code. And what it will do is it will upload that data to blob storage. So obviously make sure you're following your company's rules around network controls and everything else. But it will upload those blobs. It will chunk them. There's a little Azure function in the background that does that. It will use document intelligence to build a search engine index based on that data. And it will stand up the C# app so that it can call that search engine. And then you can chat with the data. And so when I do this with some of the manufacturing customers, what I will do is I will go on the internet and find some public PDFs of whatever that company sells, put them in the data directory, stand up the application. It takes like 30 minutes depending on how busy Azure chooses to be that day. And then the sample's ready and we can talk about the RAG pattern. We can ask questions of that company's data and let them see it for real. And so if you want to implement this yourself, feel free to take the accelerators, deploy them, upload your data into them, and then run the demos for your executives so that they can see the power and see the idea. And then if you want to use this as the basis of your app, great. And if you want to build a whole new one, that's okay too. But the idea is you can use this to quickly get started. Does that make sense?
And what services do I need? I need to have an Azure OpenAI key, and you have to, have other
Yeah, let's look. Okay.
resources.
So again, this is where, depending on the accelerator you choose, you have to have more or fewer services. This one happens to use container apps, App Insights, Document Intelligence, OpenAI, a container registry, function app, the search service, managed databases, key vaults, and several other things.
Yeah.
You can obviously structure an app any way you want to. If you don't want to use all those services, that's okay. But if you just deploy the sample app, it will deploy all this stuff for you. Now, some companies don't want to do that because they want to centralize the use of the OpenAI service. And so you would change the deployment to not deploy OpenAI, but instead just reference the endpoint from wherever your company has already deployed it.
So would you centralize the OpenAI service versus not?
Yeah. So let's see. Yeah. Yeah, let's bring that up because we can answer that. Oh, yeah. Okay. Give me. All right. So the most common way that people centralize the use of the OpenAI service is with Azure's API management service. Now, obviously, there's lots of different API management services. I won't name them, but there are ones. Azure provides one, and it provides a huge number of benefits specific around using the OpenAI service. Companies want to track every query that's coming in. They want to rate limit when people are using the OpenAI service because it's expensive. And so they want to make sure they're maximizing the utilization of the service. They want to load balance. They want to keep the history of all the queries so that they can decide, hey, we need to index more data, or we need to change the search engine index because it's not retrieving relevant results. Okay? And so the reason people deploy multiple OpenAI models, let me get to the slide that shows that. Here, whoop, too far. There we go. So this is a very common pattern people will implement. So by default, the OpenAI service that you get is on what's called the pay-go model, meaning you're paying for all the requests that are coming in and all the requests that are coming back out. But that model is shared, or not that model rather, but that underlying service is shared with everybody who wants to use Azure. And so there's very hard rate limits on it, and you will often get a 429 error saying, sorry, you're being rate limited because you're hitting the service too much. So it's fine to use the pay-go models as you get started and you're trying to play with it and understand it. But most companies that do serious implementations of this exceed the rate limits that the pay-go model provides. And so they move to what's called the PTU model, the Provision Throughput Unit model, where they're buying a dedicated instance of OpenAI so that they get guaranteed throughput. Okay? Uh-huh.
But if the pay-as-you-go model, isn't that, if that model is shared with all other Azure users?
The model is not shared. The model is always private to you, but the underlying infrastructure is shared. Kind of like with Azure Functions, if you just use the consumption model, everybody is using that same underlying VMs that run the function system, and so you may see inconsistent performance because ultimately it's a shared service under the hood. If you want guaranteed performance, you don't use the consumption version of functions, you use the premium version or the elastic version, because you're buying and you're dedicating compute and saying, I must have a certain amount of rate and a certain amount of compute. The PTU model is the same idea. If your company can justify the use of the models, because the PTU models are expensive, but they're cheaper than the pay-go model once you exceed a certain limitation and you get the guaranteed rates and the guaranteed throughput. So most companies will start with pay-go, and they may even deploy pay-go to multiple regions. They may worry that East US is overloaded or overbusy, or maybe it goes down and they want to have more redundancy. So they deploy another instance of OpenAI in East US 2 or in West US or somewhere else. And you can use API management in front to load balance between them so that if one OpenAI instance is busy, send the request to another one. But if you buy the PTUs, this makes even more sense because a PTU is like a VM. It's on all the time and you pay for it all the time whether you're using it or not. And so you want to maximize the utilization of the PTU system. So you would have OpenAI do intelligent load balancing to always send the request first to the PTU model, max it out, then overflow into one of the pay-go models if you're exceeding even how much you put on the PTU.
What's a PTU TPM?
The TPMs are the pay-gos,
Okay.
where the PTU is the provision throughput unit. Okay? So again, the idea is maximize the utilization of your PTUs because they're expensive and you pay for them whether you use them or not. Once you've maximized those, then spill over into a pay-go model.
Is there some guidance articles on this on Microsoft Learn?
Yep, yeah, absolutely. So this page and the smart load balancing, how to write the policies that do that in APIM, we have examples of all that to show you how to do it.
You say it's just like a virtual machine. Are you able to add this to a start-stop automation so it can be off at a certain?
Not with the PTUs, no. So the pay-go is pay-go. So you only pay when you pass a query in and a query comes back out. But the PTUs you have to pay for no matter what. So VM may be the wrong way to describe that. App service might be the better way to describe that because you pay for app service whether you use it or not.
Right.
You can shut it off, but that doesn't stop the bill. Okay, Adam, go ahead.
Yes, I had a follow-up question regarding the versions of the OpenAI models. You remarked that the versions of the models change
Yes,
quite a bit.
that's right.
They may involve broken API changes. Any recommendations to deal with that?
This is the ultimate bleeding edge. I mean, when we're going to look at the semantic kernel stuff, I had to change the code last week because the semantic kernel team changed the SDK that you use to build these applications. This is the ultimate bleeding edge. And those API versions change constantly. Your app is going to get broken as you try to build this stuff. The stuff you build today there's going to be problems with it a month from now because it is the bleeding edge. Yes, it will kind of settle down as people figure out the right ways to do things and the common patterns, But right now, this is the ultimate bleeding edge, and there's absolutely going to be growing pains with trying to use it.
So there's not a new version with the fix? The same exact version?
No, there's new versions, but the old versions would get deprecated much faster than we've seen with other services. Because ultimately, it's the OpenAI company that's making new versions, and then Microsoft is providing that as a service to you. But it's iterating very, very, very fast.
So it will not break in production unless I want to.
Yes. No, you'll know. It's not just going to stop working, but you will compile your app and run it one day, and then when you update all your libraries, all the class names will have changed. Or the API calls will change, or the parameters you pass in will be in a different order. This is the ultimate bleeding edge. It really is. But it's not going to break your app in production, no. That stuff will still be there, and you'll get a ton of warnings saying, hey, this model has been deprecated, we're going to shut it down in 3 months, move to something else. So you'll get a ton of warning. But compared to other Azure services, this moves really, really, really fast. Okay? Any other questions before we keep going?
This is in production.
Oh yeah, very much so.
It's not in development.
Oh yeah.
It's still in development, but it's in production.
Oh yeah, this is a GA service.
Available today.
Yep, this is a GA service. It's in some Azure regions, not all of them. Depending on the specific feature you want, there are some that are still in preview or public preview. But the OpenAI service itself is absolutely available, and you can build the same kind of apps that I'm showing you right now. And companies have and are doing so as we speak. Okay?
So that includes the licensing cost of the model, right? The model?
Yes, you don't pay separately for that. You're paid based on either the PTU, if you purchase that, or the tokens you pass in and the tokens you get back on the pay-go model. There's no separate license associated with OpenAI. Because again, you're paying for it through Azure. Obviously, if you went to the OpenAI company and went on their website, you'd pay separately for that. But we're providing an instance that's inside your Azure subscription and is billed the same way. Okay? All right, excellent questions. Okay. Are there any other questions about that first accelerator or the ideas behind it, how it works? Oh, one more thing we can look at is the code. Because the code for this is very simple. So this is Visual Studio, and this is the code that came with the accelerator. Okay? So we can ignore the front end because the front end doesn't really matter. What's important is this back end. So we have an API called the reply async function on this API. Okay? There's some various boilerplate associated with getting started, blah, blah, blah. Okay. Pass a little bit more. Now here's the important part. Here's the RAG pattern right here. On line 102, take the user's query and pass it to the AI search. So use the search query SDK. So this is just the normal Azure AI search. This has nothing to do with OpenAI. People have been building apps with this SDK for years. So take the query, pass it to AI search, and let it find some relevant snippets. Okay? So that's line 102. Go query AI search. Okay, that's going to get some documents back. There's some images if you happen to have done it that way. Now we're going to generate the chat history, meaning take the user's original question and stick that extra data that came back from AI search into the chat history. So that's adding those facts that we showed on the PowerPoint slide. Okay. Adding a little bit of more prompts. And then finally on line 184, query OpenAI. So take that chat history, which has the user's original question. It has all those facts we got from AI search. Query AI, OpenAI rather, and get an answer back. So this is the RAG pattern. It's not that complicated. It's not meant to be. It's a very simple pattern to do, and it's extremely effective and easy to implement. But it's understanding why you're doing it that's everything. The code for doing this is not that much. And you can copy the examples that we have in Python or in C# or in Java or in JavaScript, whichever language you like. But following the pattern is what's important. And then finally, remember all those follow-up questions where it suggested, here's some things you might want to ask next? Here's how it did that. So we added a new prompt saying, generate 3 follow-up questions. And then on line 211, we said, OpenAI, go generate some follow-up questions. And now we've got them, and we can pass all that data back to the front end to display. So the code for doing that RAG pattern and implementing that front-end web app that we looked at was 230 lines of code. And some of that is boilerplate stuff. And depending on exactly how you write it, you can add more or less. There was a little bit of extra for image search and some other things. But the code for doing this is very, very easy. There's already SDKs to help you do this. You can make raw REST API calls if you want to, but there's SDKs for the AI search and there's SDKs for OpenAI. And so you add those two together and it makes it really easy to implement an app that does this. Adam, go ahead.
So is there a way to find out if the data returned by OpenAI search exceeds your token limit?
Yes, so I believe the one you're going to get is, all right, so this is a APIM policy that counts all the tokens that are being used. And so a lot of people, when they implement API management in the middle between the web app and the OpenAI service, they will write code that copies out this token information. So the OpenAI service will tell you, hey, you used 1,000 tokens. When you passed it in, you got 1,800 tokens back as an answer. And so you can keep track of that. So a lot of people will store that in a database, especially if you're centralizing the service and you want to say, across my whole company, this app only gets this many tokens per minute, this app gets this many per minute, that way everyone can share the service. And so this is how you implement that, is some of the headers that you will get back will be how many tokens you've used. Now, for that specific question, yes, you will get an error saying 429, either rate limit, you've passed the rate limits for the PAYGO model, or there'll be errors saying token count exceeded. So yes, you'll absolutely get those messages from OpenAI if you exceed it. The way most people get around that is they'll use things like APIM to count the tokens and keep track of them. Okay?
Can we limit that in the OpenAI search?
Not directly in OpenAI, no. You would have to do it in something like APIM in the middle, where you would put in those rate limits to say, I'm going to count on a per IP address basis or on a per user basis. Here's how much you're allowed to do. And if you exceed that, APIM is going to block it before it hits OpenAI.
Sorry, I meant Azure AI Search. Can we limit the amount of data it sends back?
Yeah, absolutely. Yeah, you can control it. You can put in where conditions. You can put in how much data you want. Yes. So that's part of, if we go and look at the Accelerator app, that stuff would end up here in some of the overrides. So it would be here on the query document. So yes, absolutely. You can control how AI search chooses to respond and how much data comes back, how big the snippets are. But you're also in control on the input side of saying, when I chunk the documents, I want the chunks to be this big or this big. There's ways you can play with how big each entry in the index is, which will help change what data comes back when somebody queries it.
Does the term limits reset daily or monthly?
The rate limits that are directly in OpenAI are on a per minute basis. So you get however many per minute. But if you put APIM in front of it, you can set up whatever rate limiting you want. So you can set it up however you want to do it. And then on the PTU model, ultimately you're buying some amount of provision throughput. You're some amount of guaranteed throughput. Okay.
I noticed that you used the insurance as an example here, but aren't an awful lot of queries about insurance exactly the same? Does it store the information so it doesn't have to go look again?
Good question. By default, no. OpenAI, so let me phrase this really carefully. The chat completion version of the OpenAI service is stateless, meaning every single query that you pass in has nothing to do with any query that's ever been happened before. It's completely stateless. There is an experimental thing called the Assistance API, which has a persistent chat history, where you could keep track of that for theoretically ever, depending on how you want to configure it. But in general, the way to think about it is the OpenAI service is stateless. Now, if you want to put a cache in front of that, like Redis cache, you totally can. And people can do that with APIM also. Where if you have already seen this question before, don't waste tokens hitting the back end. Just go ahead and pull that answer directly out of a database or out of Redis cache or wherever you want to get it from. But you have to implement that yourself. The OpenAI service, in general, you should think of it as stateless. There's technically one that is not, but it's experimental and it's not quite ready yet.
So wait a minute, the question is cached, but it still has to get it somewhere, right? I mean, so these snippets, I think you were saying, right?
Yeah.
I mean, are those the things that are cached?
Again, nothing is cached by default. You have to choose how much you want to cache. Do you want to cache the data that came back from AI Search? Or do you want to cache the answers that come back from OpenAI? Because with the AI Search, what most people do is they implement it so it's indexing all the time, because there's new documents coming in all the time. And so maybe you want to cache that, maybe not. And AI Search does have an index or a cache in it. But ultimately, you have to decide where the caching is right, which layer you want to implement that cache in. Because by default, there's no caching at all. Because there's no way for us to predict what data you think should be cached or cannot be cached. There's no way for us to predict that. So you have to decide what can or can't be cached. Okay.
A different question. When I open ChatGPT application outside of Microsoft, so I talk and I give the answer and I follow up with another question. That my follow-up question, it means it takes already cache the first answer and send it again to the model as another.
Yep. So let's talk about that. So yes, that's an important point, that there is an answer today and there is an answer in about 3 months that will be different. Today, you have to implement that chat history yourself. Now there is a class in Semantic Kernel to help you do this called chat history, ironically, so what you see on 125. But by default, OpenAI is stateless. So the only way for you to do chat history is to store it yourself in an object or in a database or wherever you want, and then you concatenate that with the current question and then pass all of that to OpenAI and hope and pray you don't exceed the token limits. Yes. Yes. So when you exceed the token limits, then you have to compute the embedding, which is the mathematical representation of all of the chat history, and then pass that into OpenAI along with the question. So because that's kind of a pain, and because you have to do the state management yourself, that assistance API that is coming automatically does all that stuff. Where you pass in what's called a thread ID, saying this is the thread or the question series that I'm asking, persists the history forever. And it keeps track of all of it and does the concatenation for you. So there's an API in the OpenAI service that does that today, but it's beta, it's not technically GA yet. And the SDK support for that doesn't exist yet. So that's coming. So the answer today is do it yourself, and then do string concatenation to concatenate all the chat history together. In about 3 to 6 months, it'll be easier. It'll do it for you. But right now, you have to do it yourself. This is where I said you're on the bleeding edge. You're going to have to build some stuff yourself that is going to get a lot better as OpenAI and as Microsoft figure out those common patterns and what people try to implement, and try to make them easier to implement. But today, you have to do it yourself by looping over the history and sticking messages in that chat history object.
But regardless of the way, it still increase the cost for each new request.
Yep, absolutely. Yep. Okay. All right, very good. Okay. All right, so let's continue.
Sadia says LangChain. What's that?
Let me talk about Semantic Kernel first, and then I won't talk about LangChain because I'm not actually an expert at that. I'll just say I know the Microsoft first-party one. I don't know LangChain. Forgive me. All right, so let's talk about this. So we talked about the RAG pattern. It's a stereotypical pattern. Use this to implement your application using whatever search engine technology you like. Use AI Search. We think it's great. If you want to use something else, fine by us. Implement the pattern, pass the data to the large language model, and get a response back. This is the RAG pattern. You're going to implement this loop inside your application. Okay? Now, the RAG pattern doesn't just have to be AI Search. What if you have a SQL database and you want to ask questions of your SQL database? Well, I can write SQL, but we can't expect that every end user can, especially if they're not IT people. We can't expect them to write SQL. So instead, let's have OpenAI generate the SQL query, execute the query, and then answer questions based on the query. So what we can do is, this is a special kind of prompt you can set up. When you set up your web app to call OpenAI, the first thing it's going to do is say, take the user's question, generate a SQL query, here's the schema of the database. And we're just going to inject the schema right up at the top. Now, obviously, there's a limit to how much you could pass in, and an infinitely complicated schema may not fit. But this is the idea. We're going to define our customers table, our primary key column, whatever other columns are available. and let it try to generate a SQL query. Okay, so it generated a query, select customer name from customers where, blah, blah, blah. We'll pass that query to our normal search, or our normal SQL database, let the data come back, then pass that along with the question, pardon me, to the OpenAI service. So we've implemented the RAG pattern again, but we did it without AI search. We did it with our SQL database. And so this is exactly how things like the Copilots that are in some Microsoft products work. Like the Power BI one, for instance. How did it generate that data? How did it get it? How did the Excel one get it? Well, it had to query some internal system to get it. So it works exactly like this. Have OpenAI generate a query against the object model, the SQL model, whatever model has the data, pull out relevant data. Now we've got a result set. Along with the user's question, we can concatenate them together, pass it to OpenAI, and generate an answer.
The Power BI Copilot, is it token limited also?
You're getting outside of my expertise. I'm sure there are limits. I don't have a clue what they are. You've gotten beyond my experience and my knowledge. I'm not on that product team. Okay, so then we can get our final answer. Now what's also cool is it doesn't have to be SQL. You can hit ADX to get this same information. So if you have a time series database with a bunch of key values, a bunch of tags, time value and tag value, ADX is a great time series database. This used to be called Azure Time Series, and now it's called ADX. Well, we don't want the users to have to know Kusto queries and to write them. So instead, let's let OpenAI generate that query. So we're going to give it the schema of all of our IoT device readings with timestamps and devices and pressures and temperatures. Generate the Kusto query, and get a result set back. So we implement this RAG pattern the exact same way, no matter what the data source is, whether it's our AI search for unstructured data or it's one of our more structured data sources.
In this, is OpenAI actually making the query to the database or how?
By default, no. What most people implement is they do it themselves in the web app. Technically, there's a thing called function calling that I'm going to show you where you could have OpenAI call out to ADX or to SQL, but that's not what most people are implementing because that's very experimental, it's very beta, kind of works, sometimes it works right, sometimes it doesn't, but that's the next frontier, is to have OpenAI directly make the function calls out to your data sources that you set up and give it access to, of course. But right now, most people implement themselves in code in their web app.
So I was asking about the data, I guess, in step 3, the SQL result data. How you pass that data? Is it commented row, CSV, 560?
It doesn't matter. That's the coolest part of all. And I'm going to show you this when I show you the planner. OpenAI was trained on the internet. And the internet includes how to parse JSON files and how to parse CSV files and tab separated files and all the other different kinds of file formats. So there's a really good chance that it can parse it all by itself. Now, if it can't, or you need to do something very specific to that data before OpenAI sees it, that's fine. But in general, it can deal with the common file formats and the common data formats that you would see, like CSV or JSON data or XML data. So I'm going to show you that in a minute. But yes, by default, theoretically, you shouldn't have to mess with it unless it's something very specific or custom to your company. Because again, it was trained on the internet, and there's lots of examples of parsing JSON, parsing XML, parsing CSV. Okay?
Just to add to that, recently, because you're just sending text, I've seen some techniques of passing it with Markdown to try to add that extra character to the text.
That's right.
You can't get
Yes, add that additional semantic information. That's right.
Pretty interesting.
Yes, definitely. All right, cool. Okay, so the point of this graph is to show you there on the left-hand side as you go up the chart, you get more specific and more accurate for a specific task and less generic. But on the bottom, it gets more and more expensive to do this, both from a complexity standpoint, a cost standpoint, and a training data standpoint. Most people need to be right there, where RAG is. The idea of showing you this is to show you that for most people, you don't need fine-tuning. You don't need to build your own generative AI model. There's 100% reasons to build your own ML models. For anomaly detection and other stuff, that's very, very common and makes a lot of sense. But for generative AI, Most people don't need it. Most people want a system that can understand human language, and then it's up to them to pass in the right human language for it to be able to reason over and make an answer. Most people need to stay right there where RAG is. And that's not me trying to tell you how to build your apps or tell you what's right, but based on our experience, most people need to land right there. And they can build that quickly and easily and at a very low cost. But as you get further and further right, it is going to get more and more expensive to do this, both from an Azure cost point of view as well as the complexity of your app. Okay?
On that, it says RAG and React.
Yeah. So the React pattern has to do with function calling and planners. I'll show you that in a second. So we'll get to that one. So the idea of building these applications is on the bottom, you have your AI infrastructure, so OpenAI. At the top, you have your app yourself. And then in the middle, you have this idea of AI orchestration, where you need to decide, how do I pass in data? What's the flow of my application? What are my data sources? Where do I get that data? Where does it come out? And that idea of AI orchestration, the way to make that easier is with a software development kit, an SDK from Microsoft called Semantic Kernel. So Semantic Kernel is not an Azure service, and it doesn't cost anything. You download it off the internet. It's a NuGet package, or it's a JavaScript library, or it's a Python module. But the idea is, instead of you making REST API calls directly to the OpenAI service, you can totally do that. There's nothing wrong with that. But to make it easier, and to do things like that chat history object that we looked at, and being able to build plugins that can make function calls, to make that easier, Microsoft has created an SDK that you can use to build your applications, and that SDK is called Semantic Kernel. Now, LangChain technically does a lot of these same things, but I'm not an expert in that, so I can't really tell you much about it, other than I know it's there. Semantic Kernel is what I know, and that's the first-party library from Microsoft to make this easier.
Can I call like Llama or other models with Semantic Kernel, or just Azure?
Yes and no. It depends on the implementation. There are some plugins to the most common models, like Llama I think does have one, but some of the less common ones, you would have to build a plugin yourself to call them. But that's part of what Semantic Kernel is doing, is giving you a framework so that you could build your own plugin to something that's very specific and custom to you. But they're trying to make it simple and easy to call the most common models. Okay?
If you're accessing this over the web, I think Semantic Kernel can help you build your web apps.
That's right.
In order to do that.
Yes, yep, that's right. So Semantic Kernel has a whole bunch of different things built into it. The important parts for most of what you will do are the semantic functions up at the top, the AI service providers, so the specific models that it can call, memory, which is storing all those embeddings and accessing those embeddings, and then native functions, calling out to external applications to retrieve and send and receive data. So this is kind of how it's organized. Unfortunately, the names change all the time, and so this slide is also out of date. The Semantic Kernel team just dramatically changed all of this on December 15th and broke all of my demo apps. And then they released the Python app last week and destroyed all my Python demos. It's great fun, you know. You got to be on the bleeding edge of this. Okay? So when we talk about how to orchestrate and how to build, here's 3 different RAG patterns. These are all the same. They all get you the same answer, but Semantic Kernel makes it easier to do this. So the model at the top, there is a built-in functionality in Semantic Kernel to search what's called memory. Memory is a database that has all those vector embeddings. It can be AI search. It can be a Postgres database. There's a couple of different ones. So Semantic Kernel makes it easy to do that. And it can do it all by itself. Or you can be in control. And so most people end up in this bottom option. There it is, where they implement the pattern that we talked about. Semantic Kernel tries to make this easier by having built-in support for searching AI search, but you can't control the search query. You just have to hope and pray that it asks the question correctly, passes it to your AI search, and gets some data back. Most people implement the bottom pattern, which is call AI search themselves, set up their query themselves the way they want to do it, and then call OpenAI. Okay? All right, so now let's do something cool. Let's talk about the orchestration and a way you could do this. So pretend like we have a web app, and we have indexed a bunch of movies. We want to build a web app for movies. Okay? So we built a search engine with AI search to index a whole bunch of PDFs that have something to do with movies. So whenever somebody asks a question about movies, query the movie index, pass the answer to OpenAI, and let it generate an answer based on that. Okay? Implement the RAG pattern. So that's cool. That works really well. But what happens tomorrow when the business comes back and says, hey, we got all this extra data, the song data, a totally different domain. We still want the same web app because we like the interface you built, we like the POC and the MVP you rolled out, but now we need to index more data. And that data has nothing to do with the movies data. And in fact, we have to keep them separate. So pretend like this data has access restrictions on it. Maybe one side is the HR data and the other side is the financial data. Well, if you're not in the C-suite, or you're not on if you don't work in the finance department, you're not allowed to see that finance data until after the quarter closes. So we need to have it indexed separately, and we need separate access for that data. But ultimately, our web app presents the same interface to everybody, because that's the business decision of how they chose to architect it. Yes, you could have built two apps. But in this case, the company wanted to index multiple different domains of data, but they wanted AI to choose which index to hit for any given question that comes in. Yes, you could have a little combo box in your web app that chooses which index, but wouldn't it be better if AI could figure it out on its own? And the answer is yes, and it totally can. And so you can implement this idea of the intent plugin, where when a user's question comes in, figure out the domain of that question so that you can hit the appropriate index. So instead of me implementing a combo box or asking the user, what is the domain of your question, have AI figure it out based on the question that came in and based on the sources of data that the system knows about. So this is a very, very simple orchestration that you can implement. Yeah.
Question for you.
Uh-huh.
That is great. Only thing is, if the user, as you were pointing out, is not allowed
Right.
to see,
Mm-hmm.
and because these are non-deterministic models,
Mhm.
what if the intent plugin
Right.
messes up?
It totally can. Absolutely. So there's two ways to think about that one. One, you have to be okay with the non-determinism. You have to decide, is that okay or not? But then, when you actually query the data, you can absolutely make sure that the user's in the right group. So for instance, AI Search integrates with Entra ID groups. And so you can absolutely say, for this user, you know who they are based on the JOT token that came in, check in AI Search index, because with every index, you can say this document can be seen by these user groups. So make sure that the user's in the right group before you return any data.
Right.
Because OpenAI doesn't know anything about security at all.
Exactly.
AI Search does. And so you absolutely can say, this user is allowed to query this index or these documents inside the index, but not these other ones. And so you don't use the intent plugin for authorization at all, because it's non-deterministic. You can't guarantee that it will make the right answer. You use the intent plugin to try to choose the right index or to orchestrate how it makes the call. But you still need to implement the security to make sure the user is actually allowed to see any of that data before it gets past to the OpenAI model to answer.
Suppose the user is able to access both sets of data.
Mhm.
And the AI search finds results in both sets of
Yep.
data, and then it can come back and say, hey, do you want this or do you want that?
It potentially could, and that's where that user experience comes back in, where you have to decide what is the experience you want the user to have. So the company that I was working with to implement this idea, obviously it wasn't movies and songs, but they had multiple lines of business, and they wanted to make absolutely certain that when somebody asked a question about one of their lines of business, it never answered with data that comes from another line of business, because there was never any overlap. So these companies, it was a big conglomerate, and they sold multiple different product lines. No one would ever ask a question that crosses both domains between two different product lines. So in their case, it didn't matter, but obviously you have to decide in your case what that user experience needs to be.
So is the intent plugin talking to OpenAI
Mhm.
and figuring out the
Yes, yes it is. So this is what that intent plugin looks like. It's just a prompt. There's no magic. The magic is making up the prompt. So I'm going to tell OpenAI, this is how I want you to behave. I'm going to pass in the user's question. I'm going to tell it, hey, please return the intent to the user. It must be one of the following strings. Here's the switch statement. It is of type movies, it is of type songs, or it is of type not found. These are the only answers you're allowed to respond with. And obviously then I will write my code to look for those keywords. Then I give it examples of this is how and when you should respond with the movies index or the song index. So this is exactly what the company that I helped implement this with did. They took all their product lines and came up with a whole bunch of common questions that covered all the domains and all the common things that they get asked to filter on this is the right index to hit for any given product line. Okay? So then we came up with this workflow diagram, and I know you can't read this whole thing, so we'll zoom in. So the idea is when a user question comes in, we're going to pass it to our web app. So what was the top 40 hit of 2001? The web app is going to take that question and pass it to the intent plugin. So this is part of what Semantic Kernel is making it easy to do, is take that question, pass it to the intent plugin to figure out the intent. The intent plugin is a prompt. It's that prompt I showed you before. So take the user's question, take all those examples of here's the right type of data, pass it to OpenAI and let it reason over it and decide what the intent is. Is it the movies or is it the songs? In this case, it decided that it was the songs. Okay. Then we can do checks with Entra ID to make sure the user actually had access to the song's data. Assuming they did, then we can take the user's question, pass it off to the song index in AI search and get an answer back. It has an answer, and we can pass that back to the user. Okay?
What was the answer?
Oh, I think this one was, in 2001, it was Hanging by a Moment by Lifehouse. So, if we look at the code that does this, pretend like you don't see what was above. Yeah. There we go. Pretend like you didn't see my previous tests of this. Okay, so I did this one in Python just to prove that it doesn't have to be C#. If you like Python, totally fine. But I implemented the same kind of code, but I did that extra orchestration. So if we scroll up a little bit, the important part of this code is right, I think I passed it, here. This is the important part. This is the switch statement. Python doesn't have switch statements, you have to do if-elses. AI is going to take the user's query, it's going to have that intent plugin, which had all the examples of movies and songs, and it's going to get back a word, either the word movies or the word songs, and that is going to let me choose in code what index to hit next. There's no magic. The magic is getting AI to decide what index is right, rather than me as a developer having to do that or providing a combo box and making the user choose. Instead, I'm letting AI choose. And then in my code, I can programmatically decide which index to hit. Okay? So let's ask some questions. See how smart it is. Okay? What was the #1 hit of 1984? Is that a movie question or a song question? Could be either. It decided it was a songs question. Is that right? Is that not? Maybe, maybe not. Probably is. #1 hit of 1984 was When Doves Cry by Prince. Okay? The magic is that it chose the search engine index on its own, based on the user question or based on the chat history if this was a long-running query. I didn't tell it up front that it needs to search for songs. All I did was pass in a human question and let it try to guess. Okay? So let's try again. Let's see how smart it is. Who starred in the movie Dodgeball? I didn't say movie, I just said who starred in Dodgeball. It decided that my question had something to do with movies, and then it said Vince Vaughn and Ben Stiller just starred in that movie. Again, the magic is not that it was able to search the PDFs that I uploaded that have all of the top hits and all the top songs and all that stuff. The magic is that AI figured out the intent of my question and orchestrated which AI search to call without me hard coding any of it.
So the idea here is that intent plugin is a router.
Yes, that's right. Yep, that's exactly right. The intent plugin is just like what I showed you in the PowerPoint. The intent plugin is exactly what I showed you. It's take the user's question, here's the answers you're allowed to respond with, the word movie, the word song, the word not found, and then here's some examples of movies and songs. And so the customer that I implemented this with did exactly this. They took all their product lines and added example questions for those product lines and just said, and explicitly said, AI, if someone asks this kind of question, it has to do with this product line or that product line. so that they could have one chatbot that could index multiple different product lines. But they knew absolutely that they would be kept separate, and it would only query one of the search engine indexes.
So, just to better understand, so
Mhm.
like let's say we're dealing with the company Honda, which makes a bunch of different products.
Yep.
But we ask what the miles per gallon for an Accord is,
Mhm.
and we'd be able to pull that and not give us for a motorcycle.
That's right.
Or
Yep. That's the idea.
Okay.
Obviously, you have to structure it a certain way, you have to provide examples, and you may even have to ask the user clarifying questions. That's super common for the AI system to come back and say, hey, I didn't understand what you said, please try again. Provide more information. But this is the idea, is we want to try to do more of the orchestration in AI and less of it in code. So that I don't have to write a bunch of combo boxes or ask the user a whole bunch of questions to even get started. I want to let AI try to do it on its own.
How close is this to the concept of an agent?
It is the exact same idea.
Okay.
Yep, this is a very, very simple agent. Yes?
What is an agent?
And how is it trained? The agent. In other words, how is intent plugin able to figure out that you mean this and you mean that? You want to go here,
Right.
you want to go there?
So it's not trained. All we have to explain to the system what to do is this intent plugin and this prompt, where we have explained, here's some common questions, common keywords, they mean choose this index. And so your job as the prompt engineer is to come up with that and to test it and be able to get the system to choose the right path, or to ask a clarifying question if it didn't choose the right path. Okay?
Question on agent. Agent makes intermediate decisions on your behalf.
Mhm.
Or maybe there's a more sophisticated way to
No.
describe that, but it makes those choices
Mhm.
for you.
That's right.
So that you don't have to, like you
Mhm.
mentioned, hard code every if
That's right.
then
Yep.
statement.
Yeah, the idea is you want to keep calling OpenAI over and over again to try to be more intelligent about how it orchestrates the call and the flow of the user's question through the system. So you can make up these agents. Like I could have restructured this in the agent format to make an agent, the intent agent. And so my question goes to the intent agent first. It decides what index to hit, retrieves the data, then passes it back to my original system to answer the question. So you could structure it a little bit differently. As you go further and further and make more and more complicated things, the agent idea makes more sense, where the agent could have access to multiple different data sources and could have very specialized prompts for just these type of data sources versus those type of data sources. But that's very much an experimental and very much a new thing where there's not great support for that yet, and there's not good patterns to follow yet. Everyone's still trying to figure out. It's as bleeding edge as it gets.
You can think of it as the same OpenAI model in having role playing as well.
Okay. All right, so that was fun. Now I'm going to show you the best part of all. This is the most experimental, the least deterministic option, but the absolute coolest option. However, this is not GA. You cannot guarantee the responses. I can't guarantee it will behave during the demo. We're going to find out. But this is the ultimate future of where you want to get to. So we've talked about the RAG pattern. RAG pattern is great. Implement that first, always, no matter what. It's simple, it's effective. But the next step, remember that RAG pattern? I have to implement it myself in code. You saw my C# code, you saw my Python code of query a data source, retrieve some data, pass it to OpenAI to make a response. Wouldn't it be great if it could do that all on its own and me not write any of that code? Me not write any code to parse inputs and outputs. Me not write any code to have calls out to APIs. It figures it out on its own based on the user question that comes in. That's like the ultimate. That's the future. And so that's what the planner promises. Whether it does it or not, maybe, maybe not. But the idea is I want it to figure out the order of operations. I want it to call functions. I want it to get data back, parse that data, and pass it on to the next step all on its own. So the planner can do that. So let's take an example. Pretend like you're Academy or REI. You sell outdoor sports equipment, and you want to build a customer support bot for the customers who are hitting your website. Okay? So what are the common data sources that a customer service agent would need access to if you worked for Academy? Well, you would obviously have access to the user's order history, right? Maybe that's in your SAP system, so that if a person calls in and says, hey, what's wrong with the thing I bought, you know what they bought. You would also, since you're selling outdoor sports equipment, maybe you have access to the weather system so that you can say, so that if somebody calls in and says, hey, what should I buy? You can go hit the weather system and try to figure out what should they buy. You obviously have a product catalog of all the things your company sells, and that could be indexed with AI search. It doesn't really matter. The important part is we've got all these plugins, data sources, external data sources that don't know anything about AI, don't know anything about OpenAI. They're just data sources, either publicly accessible ones or ones inside your company. So a user question comes in. Will my sleeping bag work for my trip to Patagonia next month? The RAG pattern cannot answer that question on its own. That's way too complicated. There's not enough context. What on earth is my sleeping bag? Where on earth is Patagonia? What is next month? As a human, I can figure out all those things or go query data sources to get that data. But the RAG pattern by itself can't do that. AI search doesn't know anything about that. It's a search engine. But we can use it to orchestrate a complicated workflow. So, my sleeping bag, we want AI to say, that means I need to go into the order history system and figure out what did they buy? Which sleeping bag did they buy? Once I know that, I can call the order history, or pardon me, the product catalog system and say for product catalog ID 12345, what are the specs of that sleeping bag? What is the highest and lowest temperature it can support? That's not in the order history system, that's in my product catalog system. I need to make 2 calls to make that data available. Where on earth is Patagonia? Well, that's a very large geographic area, so I have a service that can give me GPS coordinates because the weather service always needs GPS coordinates. So I need to call a location service to say, what are the GPS coordinates I need? And maybe I have to ask the user for that, but in this case, we'll just guess. Then, once I know the GPS coordinates, and next month, it can call the weather service and say, what is the likely expected temperature that the user should expect to experience? Once I know all of that information, I can finally answer the question, yes, your elite sleeping bag is rated at 21 degrees Fahrenheit, which is below the average temperature in Patagonia in this month, or next month rather. So this is a super complicated workflow with 4 different data sources. I, as a programmer, do not want to have to hard code this through the system, because there's no way for me to guess every question a user is going to ask. What I want to do is provide data sources and let OpenAI figure out the order of operations and call these services on my behalf in the correct order all on its own. That's the promise. That's not a guarantee. It is non-deterministic. You cannot guarantee it will behave this way, but that's the promise, and that's what you want. And so the planner promises to be able to do that. So let's look at a demo and see how lucky we get today.
Will OpenAI come back and ask the user, let's say the user didn't buy the sleeping bag from Academy. Will OpenAI come back and say, hey, I don't see your bag, can you tell me more about it? Or
you would need to structure it that way. Okay. So you would need to, as part of the prompt, say if you can't find the user's purchase history, fail or fall back and say, hey, you need the user to clarify which one did they actually mean if you can't find it on your own. So you would have to add that to the prompt to say, this is how I want you to behave. OpenAI doesn't know how you want it to behave. You have to decide the customer experience you want to have. So we got lucky in this case, and I'll show you how it doesn't do this correctly in a second. So I set up my chatbot and I said, hey, does my sleeping bag work for my trip to Patagonia next month? And it replied back, yes. Your sleeping bag should work next month. The lowest temperature of your sleeping bag is 5 degrees Fahrenheit. The lowest temperature in Patagonia is 30 degrees Fahrenheit. Therefore, you're good to go. So how did it come up with that answer? Let's look. Okay, so here's that same flow diagram that I showed you before. Okay, now the magic is this step happened before we actually started running. Right after we got the user's question, the chatbot is talking to itself. It made a call to OpenAI saying, hey, please make up a plan that can answer the question the user gave and all the data sources. You can't see it here, but I'll show you the code that does this in just a second. This is the plan the system is going to follow. It's going to say, all right, step 1, retrieve the order history from the user, Dwight Schrute, using the order history plugin, then check the product specifications, then check the weather, then check the lowest supported temperature, and finally send an answer back. The magic is I didn't come up with that plan. OpenAI figured it out on its own based on the data sources I gave it and the question that came in. And I'm going to show you how it did that in just a second. But this is the plan we wanted, so it worked correctly. If I run it again, though, there's a good chance it won't work correctly. So I'll show you that just to prove that I'm only mildly full of it. All right, so the first step is we need to call the order history plugin and pass in the username Dwight Schrute. How did that happen? So as part of my prompt at the beginning of the call, I added the username into the prompt based on the signed in user. So I just grabbed that out of the JOT token. I know who the user is when they signed in, so I'm just going to add that to every query. I'm not going to ask the user, who are you? I know who they are. They're signed in. The magic, though, is the planner looked at my order history plugin and looked at the parameters that need to be passed in. One of them is called username, and it grabbed username out of the prompt and put it in there. I didn't do that. It figured it out because it knows how to call an API, and it knows about passing in JSON data, and importantly, getting JSON data back. So this is the data that comes back from my order history service. My order history service doesn't know anything about AI. It was generated years ago. It's a wrapper on top of SAP. Doesn't know anything about OpenAI at all. It returns some JSON data with order IDs and order dates and totals and blah, blah, blah. But magically, OpenAI needs to figure out that the most important piece of information is that product ID, because the next step needs something called product ID. And so OpenAI is talking to itself and reasoning and saying, hey, here's some JSON data. The next step of the process needs something called product ID, so grab it from the first step. I didn't write the orchestration that does that. Okay? So now it's going to call that product catalog with the correct product ID that it got from the previous step without me doing anything. This is the magic in the promise, is that I don't want to write the code to parse this stuff. I want it to do it on its own. Okay, so it called the product catalog and it got back some data. The important piece of information is this one, the lowest supported temperature. Okay, now we can have it call the weather service to get back some GPS coordinates. And most importantly, call the weather service with the GPS coordinates from the previous step and increment the current month. So I added the timestamp as the first part of my prompt, saying today's date is March 12th. So it incremented it and said next month is 4, which is April.
So
I don't want to write the code to do that.
in a way, it is analogous to the query planner.
Mm-hmm. From a search engine, or from a database, absolutely.
Yes, okay.
Yep. The magic is that it's orchestrating the calls on its own and trying to guess what it needs to happen. And then finally it comes down and, yes, your sleeping bag will work. Here's some reasons, okay? So, yay, woohoo, it got it right this time. But I'll bet you if I do it again, it won't. Because remember, this is stateless. It doesn't know what I did. So let's see how lucky we get. I intentionally queued up one that succeeded so that you would see it. We're going to see if we get lucky the second time. The odds are low, but we will find out.
Why is it failing?
Exactly. I'll show you in just a second. Okay, so unfortunately this one's running on GPT-4. It's really slow. GPT-3.5 did much better, but my demo broke and I had to switch it to another model. All right, good. It screwed up. Now, it decided that my sleeping bag would not work. Now look, it reasoned incorrectly. It did everything right, but it still got the wrong answer. The expected temperatures are lower than the lowest supported temperature of your sleeping bag. That is not correct. It incorrectly reasoned over the data it got. So again, this is non-deterministic. You can't guarantee what it's going to do, but at least in this case, it did call all of the data sources correctly. Now, why it chose the wrong answer, I don't know, because it's non-deterministic. But it did call my order history service. It called my product catalog. It got my GPS coordinates. But ultimately, pardon me, it decided that it was wrong, even though it had all the right data. The trouble with the planner is you cannot guarantee the operations, the order, whether it will get the answer correct. This is where you have to play with it and fine tune it and give it better data, better prompts. So the magic of the planner is that it shows off the incredible power of orchestration. The danger is you can't guarantee the responses or whether it will even call your services correctly. So I'm showing you this because it's magic, but unfortunately this is one of those things where you should know about it, but you probably can't use it yet. It's not quite good enough yet.
The thought process, the sequence diagram, is the actual one and not something in your PowerPoint?
Say that one more time.
The sequence diagram, it is PowerPoint, or it is the application itself? It is a live process code?
So the sequence diagram is generated with a markdown language called Mermaid.
Yeah.
And what I did was I took the chat history. Absolutely. I took the chat history object that has all the responses of the system talking to itself and generate it live with every call, just to make it easy to reason over what's happening. Now in this case, let's see what it did. All right, here, it screwed up. This is what I wanted to show you. So it needs to call out to it made up something called the conversation summary plugin, which is not a thing. It also incorrectly called my weather service. That is not the correct GPS coordinates. That might actually be in Patagonia, because Patagonia is a huge area, and there's a good chance that that GPS coordinate probably is somewhere in South America, but that is not the exact one I wanted it to use, so I intentionally wrote the plugin to fail if it passes in the wrong GPS coordinates. In the real world, obviously, those are real GPS coordinates, and an answer would have come back. But is it right or not? Maybe not.
What elevation?
Right.
Needs more information.
Absolutely. So I intentionally wrote that API to fail if you don't pass in the right data, to force the demo to work or to not work if it chooses not to do the right thing.
How long has Microsoft Marketing been using this?
Say that one more. Yeah. This is that React pattern that was on that previous slide, is this idea of the system calling itself and coming up with its own plans. This is the most bleeding edge piece of research there is.
And that's what I think of as an agent.
Yes.
Like,
This is the ultimate, but is also the most experimental. This is not guaranteed to work right. You probably can't use this today. But you need to think about it, because that's what you ultimately want to get to, is where the AI can do work on its own and figure things out on its own. So I'm showing you this not because you can implement exactly this, or that you should, even though you can take all my code and implement the same app, but because you can't guarantee the responses, the order of operations, whether it will do the right thing or not. But you should know that it's there, and it's going to get better over time.
You know that people can give you the wrong answer also,
That's right.
right? And
Yep.
the thing with the chat, the GPT-4 is it would certainly pass the Turing test, but that doesn't mean the answer is right.
Yep, absolutely, definitely. All right, so let's look at the code that makes the planner work and how you would implement this. Okay, so I wrote a little weather service. This is just a little minimal C# API. You could have done it in MVC or any other thing you want. I did this one in minimal API, it doesn't really matter. This weather service takes a latitude, a longitude, and a month of the year, and it has a hard-coded database of answers. Okay? This API doesn't know anything about OpenAI, it's just an API. I happen to have written this one, doesn't really matter. It's just a data source. Okay? The magic is this. Okay? So down here, I have the code needed to call that API. So I, as a developer, wrote the C# code to call out to this data source. If it had authorization requirements, I could get a JOT token, whatever's required to call this data source. I'm hiding that inside this function. OpenAI doesn't know anything about it and doesn't care, and neither do the users. What I want to do with OpenAI is explain to it, when somebody asks a question that requires you to get the weather, call my function. The implementation details of how that function works are irrelevant. It can call out to an external service, it can call to a database, doesn't matter what it does inside the function. The important part of these descriptions, so lines 10, 11, 13, 14, and 15, where you write in human understandable language, this is what this function does. This is when you should call it. This is the type of data that will come back. This is what each of those parameters mean. Because this data will get sent to OpenAI when it comes up with the plan. This is how you explain to the large language model, which doesn't know anything about your data, here's a data source that you might need to answer user questions. If anyone ever asks a question that OpenAI decides is relevant to that description, call my function.
Isn't this an example of the RAG pattern? Because you're teaching the model by prompting it.
Yeah, absolutely.
Okay.
There's just 4 RAG calls in this overall orchestration, but yes, it's still the RAG pattern. That's why understanding the RAG pattern is the key to everything. Once you understand that's the pattern to implement, there's a million iterations on top of it. But once you understand that's what you're supposed to do, the code is easy. It's understanding why you're doing it that's hard. So we need to explain to a large language model in human English, here's what this function does and when you ought to call it. Here's the type of data you will get back. It is in Fahrenheit. You will get the word not found if you can't find it. Here's what latitude is and longitude is. Make sure it's a string and not JSON. So as I was playing with this, OpenAI would try to inject a JSON string instead of a double. And so it would screw up and the function calls would all fail. So this is me trying to explain to it, hey, this is what you need to pass in. It needs to be a string that will get converted to a double by C# when it ends up making the function call. The implementation details inside this function are irrelevant, but they're also specific to you. Whatever code you need to call that data source, an API key or an authorization or a SQL database, doesn't really matter. It's all irrelevant. You hide that inside this function. The only thing that's important is you explaining using these attributes or these decorators. If you were doing the Python version of this, this is when you ought to call my function. So some of the built-in plugins to Semantic Kernel are things like the Graph API. The Graph API will have descriptions like that, where for every Graph API call, here's a human-readable description of what it is and what it does, so that if OpenAI decides to do a function call, it can call the Graph API to send an email or to get the user's profile information or whatever it is that's needed. The magic is you explaining using those attributes, this is what my function does. And then you let OpenAI decide whether it wants to call that function or not.
So is that description, all that has to be passed to OpenAI?
That's right.
Is it kept in cache then to like refer back to? Or like,
No, so.
you could have, what if you had
Yes,
30
correct. Yep. Yeah,
plugins,
exactly.
a huge number of descriptions?
Yep, that's right. So let's talk about that. What you don't see in this picture, because Semantic Kernel broke all my sample code, and they didn't expose this piece. I had to find it by watching all the network calls. There is a secret call that happens right before this one, which is take all those human readable attributes, all those C# attributes, and make a one question or one prompt to OpenAI saying, go make up a plan. Here's all your data sources. And so yes, you're using tokens to do that. And you're doing that every single time. And yes, that burns a lot of tokens. But the magic is that it can orchestrate, but you can't guarantee what it does. This is very much the active area of research, and there probably will be better ways to do this. But right now, this is the only way to do this. Okay? So if we keep going down past the screenshots, this is that React pattern. This is the secret prompt that's underneath the prompt. This is how it comes up with its own plan. This is one of those active areas of research where the Semantic Kernel team figured out that if we pass in a prompt that looks exactly like this, it will generate a prompt that has the right plan that Semantic Kernel can iterate over to call all my functions in just the right order. And this isn't secret either. You can dig this stuff out of the documentation. I just happen to have found it. And obviously it's subject to change, and it's going to change over time, but you don't pass this in. It's going to do this under the hood when you make a planning call. When you call the planner, it's going to inject this into your prompt, come up with a plan, and then start looping over that plan, trying to answer the question and making as many function calls as it takes. But remember what we talked about on that previous slide? If you add too much data to the prompt, it will start to freak out, and it will start to refuse to answer correctly. So you can't give it access to 100 data sources with thousands of lines of description. Eventually you'll run out of tokens, and it'll get confused. So you still have to do work to pare down and only have the relevant data sources that have something to do with what you want it to figure out.
I have a question.
Mm-hmm. Yeah.
Would it be nice in this case to train a small language model as the router with all these prompts and more maybe, and let it route and query OpenAI? Would that be?
I still don't think you need to train a model to do that. What most people have done is they will create like a database that has things like this in it. And then the first step of the orchestration is query that database to figure out the relevant data sources, then let the planner figure it out. So they're still using the RAG pattern, they're just doing it a couple of times rather than training a model to do it. Because again, the model just needs to understand English. It just needs to understand that's what I want. But I have to give it those data sources. I have to be able to explain, hey, if you look at all my data sources, here's my data source, the weather service. If we look at another data source, like the order history service, here's the description to OpenAI of what my order history service does, when you should call it, and the kind of data to pass in. Don't put curly brackets around the username because it kept screwing that up. Why did it do that? I don't know. So I had to tell it, don't do that. This is part of that prompt engineering. The implementation details of that function are irrelevant. The important part are those descriptions at the top that explain in human understandable terms, this is what I want you to do. If somebody ever asks a question that's something to do with order history, call this function to get some data. Okay? Yeah?
This might be slightly off the subject, but in the previous slide where you had the prompts in 0 to 9, is that best practice for?
You don't have to do anything.
In doing multiple, I'm just saying in general, doing multiple steps, if you have something that does, has multiple steps, is that best practice in terms of trying to get a decent answer out?
That's beyond my knowledge. That's a PhD thing. You'll have to, that is beyond my skill set of trying to influence the AI to do what you want. That's where the prompt engineering comes in, and I can't tell you.
Okay, no worries.
It worked in this case.
Okay.
Whether it works correctly every time, I ain't got a clue.
Okay.
The important part, though, is that you don't have to do this.
Right.
But you can use it as an example, and if it works for you, great. But it may or may not work tomorrow. I don't know.
Fair enough.
You can't predict, you can't guarantee what the AI systems do.
Okay.
That's part of the fun of them, but the part of the risk. Okay, so I know I've gone just a hair over time, but hopefully I've given you a great grounding in the RAG pattern, which is the single most important thing to take from tonight. The idea of the intent plugin where you start to do orchestration. The idea of semantic kernel, which is the SDK you use to build these apps. And then function calling and the planner as the ultimate future for where you want to get to. Even if you can't get there today, start thinking about how you could have function calls to retrieve data from data sources that are beyond just AI search or just one SQL database, but are APIs or multiple APIs to get the data you want. So that's what I have for you today. Thank you all very much.
Thank you.